Welcome to the module focusing on wireless network standards and security solutions. Let's start by going back in time. Wireless LANs were first introduced in 1991 in the Netherlands. Over a short period of time, they became globally sought after. The working principle behind wireless networks is identical to the principle of wired networks that we talked about earlier, or that of networks transferring data via optical signals. They also use the TCP/IP protocol stack. A fundamental difference is in the medium, the vehicle for transmitting signal. Also, the signal is no longer electrical or optical, but uses radio waves instead. A repercussion of this difference is that unlike wired networks, wireless networks share the same carrier for all computers, all hosts, that are within the reception range of the transmitter and access point. Unlike in wired networks, a potential attacker doesn't have to run a man-in-the-middle attack, poison the ARP cache, or masquerade under a different IP address to eavesdrop on and control transferred communications. Establishing an unauthorized connection with a wireless network will remain unnoticed in most cases. It's possible to connect to a VLAN without the need for tampering with the network infrastructure. It doesn't require a physical presence in the office of a company whose network an intruder tries to break into. Any computer connected to an access point shares the medium with the other machines. This means that the data transferred over the same network, including confidential data, is in fact public. This is the key difference that separates wireless and wired networks. Whenever you connect to a Wi-Fi network and check your mailbox, or log into an important system service or a social media website, you have to be aware that all interconnected users can access your information. Security-wise, the worst scenario involves attackers taking control over the access point. They can then force you to connect to their rogue access point. This situation will be examined more closely in this and the next part of this course. Now we'll introduce you to wireless communication standards. Standard 802.11, the Wi-Fi standard, is in fact a set of standards. The first 802.11 standard had a maximum data rate of 2 megabytes per second. There's one thing you need to know as far as standards are concerned. Since Wi-Fi networks are standardized, they use the same frequency bands everywhere in the world. In contrast to CB radio or amateur radio users, we don't have to file for a permit to use a particular frequency spectrum. The same wireless card used in Europe will also work in the US, Asia, or Africa. This is made possible through the implementation of wireless standards. The original 802.11 standard was quite soon replaced with its B version. This version is fully retroactively compatible. The amendment increases wireless network throughput to 11 megabytes per second. Version A was released simultaneously with 802.11b. It's quite less popular as it is not compatible with version B or with the original standard. Its strength lies in employing a different signaling method. It also uses a higher frequency. The frequencies that can be seen in the chart in the picture are approximates only, because each standard uses a specified number of channels. Depending on a country, there can be 11 or 13 channels. Adjacent channels can overlap. You need to realize that, for example, for the B version, the frequency is never exactly 2.4 GHz. The successor of B is the standard 802.11g. It's used in business and homelands even today. It's retroactively compatible with the B version and the original standard. 802.11g can transmit data over a relatively long distance with a speed of up to 54 megabytes per second. Between 2004 and 2005, the N version of the standard was introduced and gained popularity. What gave it an advantage over the previous versions was the improved reliability and extended range of the wireless transmission. In 802.11n, the same signal can be transmitted and received by multiple antennas, or access points. Originally, the 802.11 standard used not only radio waves to transport data, it also defined infrared transmission. This standard, however, failed to achieve popularity and was supplanted with other technologies.